teacher knows best where his students make mistakes and compromise on their marks and chances. So let's start with our new series, Common Mistakes Made by Students in IPMAT Exam. To get more such guidance, you can visit our website and join our pre-recorded, live or classroom courses.
Hello students, welcome to Myprepway's conceptual mathematical learning series. So in this video, we'll be discussing about some common mistakes that you may do while solving the questions of aptitude, majorly for quantitative aptitude. And the mistake and the common mistake that I want to point out here is about the definition of prime number. Okay, so if I ask you what is the definition of prime numbers, so what do you say? I have seen a lot of students giving different definitions. For example, the first general definition is that the number which is divisible by 1 and itself is a prime number. Okay. So next definition is the number which are not divisible by any number other than itself. Okay. Third definition that I have heard of is the numbers which have two factors, only two factors. Okay, are prime numbers and so on, right? You may know any other definition of this also. Okay, so the problem with these definitions are, this definition is perfect. The numbers which have exactly two factors are called prime numbers is the perfect definition for this prime number. And similarly, if I talk about the composite numbers, so according to the first definition, divisible by 1 and itself, the number which is not divisible by 1 and itself, the opposite of this would be, the definition of composite number. The number which is not divisible by any other number, this is actually wrong, so I don't need to elaborate it. The perfect definition is the numbers which have exactly two factors which are prime number, and the numbers which have more than two factors, 2 plus factors, are composite numbers. So this is the perfect definition of prime and composite. Right. Let me first tell you why this is wrong. This is wrong because I'll give you the example. Suppose I take a number -5. What do you say? Is it a prime number or a composite number or nothing? Is it a prime number or a composite number or nothing of them? Okay, so the answer is nothing, because the definition of prime number is not applicable on the negative numbers. Okay, so divisible by 1 in itself is not a perfect definition, because this number is actually divisible by 1 and itself, obviously. So it should be a prime number, but it is not, right? Actually, it is also divisible by -1. If I just go into this particular number, so -5 is also divisible by -1. It is also divisible by 5, we can say, right? So we will say that it is divisible by more numbers other apart from 1 and itself, right? So therefore it is not a prime number. That's fine, right? But what if we have something like 3.7 plus 3.7? Okay, so is it a prime number or a composite number or nothing? 37 is obviously a prime number. So what about 3.7? Yes. So 3.7 is not a prime number. Neither it is a composite number. It is nothing. Neither prime nor composite. According to this definition, second definition, you can yourself interpret that it is wrong. Number divisible by any number other than itself is a prime number. So they have not mentioned 1 here, obviously. The limitation of this definition is that the number which is not divisible by any other number is other than itself is a prime number. According to this, -1 will also be prime, right? So limitations are there. This is the perfect one, that the number which have exactly two factors are prime numbers. The numbers which have more than two factors are non-prime numbers. And remember, factors are calculated only for the integers, right? for integers. The numbers like this don't have any factor. Okay. So 2 factors, prime number, 2 plus factor, composite number. Now, an exception or the biggest difference between these two definitions is the number 1. So is 1 a prime number, a composite number, or nothing? What do you say? So you should know that 1 is nothing, neither prime nor composite. Okay. So if it is nothing, then according to the first definition, it is prime because it is divisible by 1 and itself, it should be a prime, and it is divisible by only 1 in itself, right? I should write only here. So it is divisible by 1 in itself only, so it should be a prime number according to the first definition, but it is not. Okay, what about the second one? The number which is not divisible by any other number other than itself. Yes, 1 is not divisible by any other number other than itself, so it should be a prime number. So these two definitions fail in the case of 1. Only this third definition remains. Why? The numbers which have exactly two factors are prime. 1 is the only number, 1 is the only natural number which have exactly one factor, right? And the numbers which have more than 2 factors are all composite. You can see 4, 6, 8, 10, 9, 15, 21, all these numbers which are composite have more than 2 factors. So that's the perfect definition. So remember, you should always learn this definition, not these. These will not be applicable on this. These definitions, the first 2 definitions, fail at this number. Okay. Alright, so that's it in this video. For more of these concepts, please refer to our online courses, our physical classroom courses, and the recorded courses. Thank you.
Head over to our website and join Myprepway's pre-recorded or live course to watch the full lectures. Use coupon code MYPREP09 to get 500 off on all our courses.